Hello. Um, for this question 1a, the question given the function is fxy equal to sine x square plus y plus 2y. So first step is we need to uh, differentiate in terms of x, and then we differentiate in terms of y, xy, and then we substitute the condition, like the question already given that x is equal to 2, y equal to 1. So after we differentiate, we just substitute the value of x and y inside the function, and we will get the negative 8 sine 6 here. Okay, for b, um, actually I make it more complicated ways here, but actually what you can do is, at first they want us proof that x dz over dz is equal to 2y dz over dy. What you can do is, actually you can replace like this: z equal to fx square y, or z is equal to fw. So w is x square y. So wx, if we differentiate this in terms of x, we will get 2xy, and if we differentiate this in terms of y, we will get x square. So how do we going to prove this in easiest way? So what we can do is, so here we get 2xy, wx we can replace dz over dx, and wy we can replace with dz over dy. So so what we can do is, okay, let me show you. So just now wx we get equal to 2xy, and wy we get is x square. So from here, x dz over dx, so dz over dx we replace with 2xy. So what we get is x times 2xy is equal to 2y, and dz over dy we replace it with x square. So what we will get here is 2x square y is equal to 2yx square. So both side is same, so this problem is shown lah, which is x dz over dx is equal to dy dz over dy. So next is question C. So basically the z is equal to xy exponent power of sy, and then x is r cos theta and y r sin theta. So what we gonna do first is we differentiate z in terms of x, and we differentiate z in terms of y. And what we do is we substitute r cos theta inside of x and r sin theta in y. And the question also gives us that the value of r is 2 and the value of theta is pi over 2. So if we substitute r theta and in xy, we will get that zx is equal to 2, zy is equal to 0. So so we need to do chain rule to get this z theta and x theta. From here we will get negative r sin theta, which is r is 2, theta is pi over 2, which is 90 degree. So you will get that x theta is equal to negative 2, and y theta we will get 0. So we just substitute the value of zx here is 2, x theta is negative 2, zy is 0, and y theta is 0. We will get the answer is negative 4. So for question D, the r is 6 see x over r4, and then the question is already given the percentage. Then to find the value of the percentage, which is dr over r is equal to negative 0.2 and dx over x is 0.03. So to make it easier, we bring the r to upside, which is become r negative 4, and then we ln both sides, and then we will get rx equal to r over x, and 1 over r times r equal to negative 4 over r. So r we will get negative 4r over r. So we need to find dr is equal to rx dx plus rr dr. So we substitute the value of dx here, we already get 0.03, and then dr we already get 0.02, and then rr is 4r, and then we will get dr is equal to 0.11r. So dr over r we will get 0.11. To find the percentage, we need to times dr over r times with 100%, which is 0.11 times 100, we will get 11%.
Question 2a. The question asks us to evaluate the double integral by converting to polar coordinate. So from the equation, first we need to solve our boundary. After we solve boundary, we can sketch our region. So the region is important for us to change our equation into polar coordinate. So after we evaluate the region, we get a dr 2 cos theta 0 d theta is equal to pi over 2 0. So after that we can substitute, then we get our polar coordinate equation. After we get our polar coordinate equation, we need to solve the dr first. After we solve the dr, so we get this equation. So we can simplify the equation by substituting u is equal to sine theta and du equal to cos theta d theta. So after we substitute, we solve for our d theta. After we solve our d theta, we get 16 over 9 for question 2a. Moving on to question 2b. The 2b asks us to find the mass of the solid in the first octant bounded by the plane. So from the equation, it gives us y equal to 0, z equal to 0, z equal to 4 minus x squared, and y equal to x. So from this information, we can sketch our bounded region, and then we can find our dy, dx, and dz. So after that, we need to compute our mass equation. So the mass equation is m integration to 0 x integration x 0 and integrate 4 minus x squared 0 xy dz dy dx. Since this is a mass bounded in the first octant, so it have 3 variables. So as usual, we need to solve on the dz first. After we solve the dz, we will solve dy, then dx. After we solve the equation, we will get 8 over 3. And the last one on 2c, the 2c asks us to find the volume of the solid bounded above by the sphere. So this is x squared plus y squared plus z squared equal to 4 is our sphere equation. Then it gives that the sphere is below by the plane z equal to 1. So from the equation, we can draw our our region, our solid sphere, then we can compute our volume equation. So from this we get 2 pi 0 square root 3 0 square root 4 minus r squared to 1. So we get dz, r, dr, and d theta. So after like the previous question, we need to solve the dz first, followed by dr, followed by d theta. If necessary, like this question, we need to substitute our value so that we can solve it easily. So after we calculate the equation, we integrate, then we get 5/3 pi. Okay, moving on to question 3. Question 3 is on integral. So the first one, the 3a, we give us f equation and our gradient x, y, and z. So it asks us to find the del gradient, dot product, and also the cross product. So the first one, to find our del gradient, so we can make a vector that gradient x, gradient y, and gradient z equal to. So to find our gradient x, we can differentiate our gradient x, y, and z. So for gradient x, we differentiate respect to x. For gradient y, we differentiate respect to y, and gradient z differentiate respect to z. So then after that, number 2, find the dot product of the del's dot product del gradient. So this one is equal to px plus qy plus rz. So this is just a variable, so equal to will be equal to 0 plus 2xz plus 0. Then our dot product is 2xz. So and the last one is our dot product, where the dot product is the question wants us to find the dot product of f and del times with gradient. So this is equal to f time f dot product time cross product del gradient. So we can make a vector y j k. So to find our cross product, so if we want to find our I, we can close this one, close our I, then we can cross product. So for j and k, so we get our cross product here. Okay, moving on to 3b. So 3b, the question wants us to find the directional derivative of the scalar function. So the question gives us the gradient, and so the at point P 131 with a vector of 2i plus j plus 2k. So this question, for the question, we can list on our information. So the first one, we know that we can find that our gradient is equal to xy plus xz minus y squared minus yz. So from this, to find our del gradient, equal to vector del x, del y, vector gradient x, gradient y, and gradient z. So the equation for gradient x, so like from 3a, we can find, so we get y plus z, x minus 2y minus z, x minus y. Okay, then we can use our vector a, our a where our a direction is 2 1 2. So we get we find our vector function of a, then which we get 1/3 2 1 2. So after for direction a, then we get our del gradient vector, which is equal to 56. Square root 56. Then we find our d gradient over ds equal to del gradient times n times vector n. Okay, so from this we get that our del gradient is 4, 6, negative 2. 4, negative 6, negative 2. Dot product with 1 over 2, 2, 1, 2. So thus we get our unit vector, the which our gradient increase most rapidly at B, our unit vector. There we get 1 over 56, 4, negative 6, and negative 2. So then moving on to 3C. So the question on 3C is about the vector field. So the vector field of F is conservative. So the question asks us to show our alpha and beta. After that, we need to find our potential function. So the first step is we list our information, then we find our cross product, of del F. So to find our cross product, so we get this after we cross product. So with the cross product, to find our to show our beta and alpha, so we can take this equation, equate it to 0. So we get beta is equal to negative 2 and alpha is 2 over pi. So okay, alpha equal to 2 over pi and beta is equal to negative 2. So we already show. After we show that, to find our potential function, we can take our gradient x, gradient y, and gradient z. So we compute the equation. So we get this. So the potential function for f, where f is equal to del gradient, we get this one, x squared over pi sine pi y minus y squared exponent negative z plus c. So this one we take our value of alpha and beta. So we substitute in our equation here. So then we get our potential function.
Okay, this is my question. So the first one is to evaluate the integral. Okay, so first, here is given the limit for t and already given rt. So what we need to do is to differentiate with respect to rt with this one. We determine the xt, yt, zt is from rt, and then we differentiate because we want to find the ds. This is a ds. To find ds using this formula, so we insert the differentiate value of x bar, y bar, z bar, and then we get dt. So in order to find this, we need to have ds. Okay, and then we use the limit given and we substitute the value of xt, yt, zt into the equation, and we will get 2 pi. So this is very simple question. So the next one is to find the line integral independent of its path. To find the work done on a particle, force F. Okay, so again, limit is given and RT is given. So write it down. So the first part is we need to find the curl. We need to prove that the curl is 0. So using the cross product of the gradient and the f ijk, and then we will get all the points ijk is 0. So hence we have proved that the curl is 0. And then the next one is gradient times phi. So we need to done it one by one because we want this equation, the phi equation. We want to do it one by one. So f1 is delta phi over delta x. So this one is differentiate with respect to x, and then this is what you get. Again, f2 is differentiate with respect to dy, and f3 delta z, and then all of this we include to the final phi equation, and then the c1 we can combine it to become a big C. Okay, so again, we not given point. We did not be given the initial point and the final point, so we need to find the point first. So for the initial point, using the limit given, we substitute the value of x cos t, y sin t, and z t 2 pi, t over 2 pi, so we get 1 0 0. For the final point, we use the t equals to 2 pi, and then we will get 1 0 1. And then we substitute all of this to this w, the work done. We need to find the work done, right? Yes, we need to find the work done. Okay, so formula is using this one, and the phi of the initial point minus the final point. So we using this equation from the phi here that we calculated before. Substitute the value x, y, z, substitute, and then we get 1 plus c. This is the final point, and then this is initial point because final minus initial. So this is, we get this one final and the initial. To find out done, we minus this, we subtract, and then we get 1. Okay, next question. C is using Green's theorem. Okay, we need to evaluate the line integral. This one. Assuming that C is oriented counterclockwise. Means, is it positive? Okay, so from this equation, y equals to x squared and y equals to 2 minus x squared, we need to draw the graph first. So this is the graph that we get. So the intersection is here. Okay. Then what we need to do is this is the equation. This is the equation of the Green theorem. So I figure this out first to make it easier here. Okay. Then delta f1 over delta y, delta f2 over delta x, and then we substitute into the equation of the Green theorem. Then This one is a dy dx, which means it's a type 1. So cut here along the y-axis. So again, substitute here, and then here is from integration again. So you can see x squared is this line, and 2 minus x squared is this. Then this one. Okay, and then substitute, integrate 1 by 1, and this is what I get, 32/3. Okay, thank you.
In this question 5a, it is regarding the surface integral of scalar field. Firstly, we need to sketch the solid of integration. It can be seen that the yz plane is easy to integrate, so we take the yz plane. Then we need to find the ds. The formula of the ds is like this. Then after we find the ds, we can find the line integral by substitute the ds inside. Then we solve the integration. There's a 2 in front of the line integral because we have 2 sides. For question 5b, it is regarding the Gauss theorem. Firstly, we solve the equation by completing the square. Then we sketch the solid of integration. As the shadow is shown on the xy plane, so we take the xy plane for the integration. Then from the Gauss theorem formula, we need to find the divergent f. After finding the divergent f, we find the limits of integration. Then we substitute all the information into the equation and we solve the integration. For question 5c, it is regarding the Stokes theorem. Firstly, we sketch the solid of integration. Then we sub the equation f dr. Then after that, we find the rt and find the drt. Then after finding all the information, we sub into the equation 1. Then we do the integration.